Technology and Alabama Science in Motion. Hello, my name is Candace Golliver, and I am the chemistry specialist with Alabama Science in Motion out of UNA. I'm doing this presentation for my EDT 703 class in the fall of 2007. Let's begin by looking at technology standards, specifically the ISTE standards, the Alabama State Department Teacher Leader Standards, as well as Instructional Leadership Standards, and the 2015 Alabama Course of Study Science Standards. First are the ISTE standards, the International Society for Technology in Education standards. They are to facilitate and inspire student learning and creativity, to design and develop digital age learning and assessments, to model digital age work and learning, to promote and model digital citizenship and responsibility, and to engage in professional growth and leadership. I feel that with Science in Motion, teachers are able to accomplish these standards. The next standard I feel applies to myself in my job as chemistry specialist with the Science in Motion program, and it's the Alabama State Department of Education Teacher Leader Standard number 1, to use comprehensive knowledge of subject matter and student development to provide resources and coaching to colleagues designed to enhance their ability to select, organize, and present factual, conceptual, and procedural knowledge in ways that deepen all students' understanding within and across content areas. Also, the Instructional Leadership Standard number 4 and 5, to develop an effective teacher professional development plan to increase technology usage, to support curriculum-based integration practices, and to promote the effective integration of technology throughout the teaching and learning environment. I feel that the Alabama Science in Motion program meets both of these standards. Let's look at the standards from Alabama Course of Study in Science. These standards incorporate the science and engineering practices which can be implemented with the use of technology. They are to ask questions and define problems, develop and use models, plan and carry out investigations, analyze and interpret data, use mathematics and computational thinking, construct explanations and design solutions, engage in argument from evidence, and obtain, evaluate, and communicate information. Let's look at the Alabama Science in Motion program itself, the history of the program, goals, and technology that we use in Science in Motion. The Alabama Science in Motion program, abbreviated ASAM, is a statewide program that provides prepackaged biology, chemistry, and physics labs to high school students. We provide 5E inquiry-based labs and lessons aligned with the new Alabama Course of Study standards, provide training and professional development to teachers, and we provide ongoing on-site assistance when requested. How did the program get started? Well, in November of 1993, 2 Alabama state senators, Fred Horn and Hank Sanders, were watching TV and they viewed a video about Juniata College in Huntington, Pennsylvania. They decided to take a group to Juniata College and to view their Science in Motion program. In May of the following year, the governor signed the Alabama Science in Motion legislation. In August of that same year, 1994, the first teacher training workshop was conducted at 6 pilot regions. The next week, specialist visits started at those 6 pilot regions, and the program has grown ever since. In 2005, ASIM combined with the Alabama Math, Science, and Technology Initiative and added its 3rd specialist at all 11 sites. The Science in Motion program is a grant-funded program. It is a line item in the Alabama State Department of Education budget, and it also gets funds from AMSTA. How does ASIM reach the state? Well, it has 11 in-service regions, each based at a state university. Each region has 3 specialists, 3 trucks, vans. That's biology, chemistry, and physics. So, for example, UNA, which is Region 1, right here, we serve 6 counties and 34 high schools. So we have a total of 33 Science in Motion specialists throughout the state, providing professional development and on-site assistance to teachers. Some advantages to teachers. Teachers get excited about teaching and about science again. They get to network, interact, and exchange ideas with their peers and create those learning communities. Teachers help develop and improve experiments that Science in Motion provides, and those improvements can impact classrooms in the entire state. So teachers do have a say in the lessons, in improving the lessons, editing the lessons to help make them better. Also, specialists and teachers do a co-team teaching if the teacher has large classes or difficult labs. Science in Motion provides teachers with opportunities to share and expand their content knowledge, and helps bring real-world examples back to share with their students. Teachers learn how to use data acquisition devices to enhance laboratory experiences. They work with each other, troubleshooting, so that when they go back into the classroom, they can help their students troubleshoot. There is a sort of a steep learning curve on learning how to use all the data acquisition devices. And so if the teacher needs help in the classroom when they're first implementing these labs, the Science in Motion specialist will go in and help out until the teacher feels comfortable. There are lots of advantages to students because it is all about the students. Science in Motion program helps to increase student interest in science by students getting to use state-of-the-art equipment such as analytical balances, data acquisition labs. Here we see students using microscopes. Science in Motion also provides equity of opportunity for students across the state, regardless of what high school the students are in, whether it's a poor school or a well-off school. Every student gets the same opportunity with the Science in Motion technology. Science in Motion reaches students with different learning styles. It helps to foster cooperative learning, inquiry, and helps prepare students for college or for technical school. Here we see students learning how to use analytical balances to get them ready for college and for career laboratory experiences. Some of the goals of Science in Motion. Number 1 is to complement, enhance, and facilitate implementation of the Alabama course of study in science. 2 is to provide students with laboratory experiences using state-of-the-art scientific equipment to prepare students for college and the workforce, and to increase student interest in science and science careers. 3 is to provide high school teachers with professional development opportunities that will enhance their content expertise, their technology background, and instructional skills. And 4, to provide equity of opportunity for students across the state, regardless of the public school they attend. I conducted some surveys with the specialist to see what they thought about Science in Motion and its incorporation of technology, as well as with some Science in Motion teachers to get their thoughts. So for the Science in Motion specialist, I used the app GoFormative. And so I sent out a link to the teachers where they could go to the GoFormative website, enter a code, and then answer the questions, and I could see their responses. I asked them 3 questions. I had 8 specialists respond. The questions were, how does Alabama Science in Motion help teachers incorporate technology in the classroom and the lab? What other ways does Alabama Science in Motion help teachers incorporating that technology? And 3, what more do you think Alabama Science in Motion could do or add to help teachers further incorporate technology in the classroom or lab? So when we start looking at the results, on number 1, asking how Science in Motion helps teachers incorporate technology, I gave them 5 choices. 1 was the use of data acquisition devices, such as Pasco GLX, the Vernier LabQuest, computers and interfaces. 2 was the use of data analysis software, such as Vernier's graphical analysis and Pasco's Capstone software. 3 was the use of other high-tech equipment, such as analytical balances, microscopes, spectrometers, MELTAMPs, gas tubes for analyzing atomic emission spectra. 4 was the use of computer simulations to enforce a concept incorporated into the Science in Motion labs and lessons. And 5 was the use of videos or tutorials to enhance a concept. And so when I started looking at the specialists and which ones they had checked, most specialists who took the survey had checked all 5 boxes. This person only checked 4 of the 5, and same here. And I don't have all 8 showing. One of them, what was below here, did not show up. When we look at question number 2, it's a short answer question. What other ways did the specialists feel that Science in Motion supported teachers and technology? Here are some of the short answer responses. One person said that students learn how to digitally analyze and interpret data from graphs to get ready for the ACT and for college and career. And I thought that that was a good point, and so I added it to the teacher survey. 2, during professional development training days and during the school year via email, ASIM recommends websites and apps that teachers can use with students to enhance learning. I also felt that was a good one. 3, teachers can upload copies of Science in Motion labs for students to access with their devices prior to doing the lab. And 4, Science in Motion provides training on equipment and the use of labs that incorporate that technology. So all of those I felt were good short answer responses. Now for the 3rd question that I asked the specialist, what more do you think the program could do to help teachers? Here are the responses I got. They said that Science in Motion could video specialists, teachers, students, all 3 or just one set, performing labs and post them with questions for online teacher training. Also, if a student misses a lab, he or she could watch a video of the lab and then analyze a data set to answer questions. Since they couldn't be there to actually do the lab, they would still be getting what they needed out of the lab. Another response was more training, specifically targeting the use of technology in the science lab. One specialist mentioned 3D printers, that we could have lessons on choosing the print medium based on use. Students can build and print molecules, and those were just some examples that they came up with. Number 4, one specialist said, since most schools are Google schools, the use of Google Sheets or other Google products for labs, for data collection, for analysis, or even to share data across multiple schools to increase the sample size. So I thought that was a good response. Hopefully, we'll incorporate that soon. Another specialist mentioned sharing resources digitally using Google Docs. And another specialist said helping teachers set up electronic science notebooks and providing PD on how to use them effectively. And so I'm hoping in the future that our Science in Motion program will start to incorporate some of these suggestions from the specialist. Looking at the survey that I gave to the Science in Motion teachers, I collected data using Google Forms. I sent them a link, and I had 13 teachers respond. The questions that I asked were, how does Alabama Science in Motion help you incorporate technology into your classroom or lab? And what more would you like to see Alabama Science in Motion do or add to help you further incorporate technology in your classroom? And so I'm actually going to click on the Google link. Let's go to it through the website. Alright, so here I have the Google form. See, one page was set up with questions. This is what the teachers saw, and they went through and checked the responses. And then when we actually look at the responses, it gave me a bar graph so I could see how everybody answered. So when we look at the first one, labs that use data acquisition devices, such as the Passcode GLX, the Vernier LabQuest, and computers with interfaces, 12 of the 13. So that's one way that Science in Motion helps them to incorporate technology. And that's one of our big ways. We have lots of labs that make use of the data acquisition devices. The second one, we had 11 of the 13 teachers say that labs that use data analysis software are important to them, such as Vernier's graphical analysis and Passcode's capstone software, where they can analyze graphs as well as analyze videos. All 13 teachers said labs that use other high-tech equipment are important to them, such as using analytical balances, microscopes, spectrometers, mel temps, and so forth. All 13 mentioned that students learn how to digitally analyze and interpret data from graphs to get ready for the ACT and for college and career. 10 of the 13 mentioned that they use computer simulations incorporated into the Science in Motion labs and lessons to strengthen conceptual understanding. 10 of the 13 also said the use of videos or tutorials that are incorporated into the Science in Motion lessons are important ways to help them incorporate technology. 9 of the 13 are making use of being able to upload copies of the labs so that students can access those with their devices prior to doing a lab. So they can read the lab ahead of time, copy it into a science notebook or an electronic notebook, or they can take their devices just straight into the lab and read the procedure off their device. And all 13 teachers checked that during PD training days, during the school year, that Science and Motion specialists recommend websites and apps that teachers can use in their classrooms. 2 of the 13 marked other. I wish that I would have given them a space to elaborate on what they meant there. Hopefully next time I'll remember to do that. When we start looking at the second question, and there's short answers, what more would you like to see Alabama Science in Motion do or add to help you further incorporate technology in your classroom or lab? Here are the responses. One mentioned a quick reference guide for equipment. Another teacher mentioned more real-life examples, letting them know why it's important for them to learn it. This teacher says that they would like to learn how to use a graphing calculator. So maybe that's something that we can work with them on in a training. Another teacher said that they would like some training tutorials on popular educational software apps. And so maybe that's something that we can work in for them. We had quite several teachers, give us praises, which is appreciated. Here someone says that they would like to see the course of study objective that's listed on the website written out without having to open the lab. And so that's something that we can easily get fixed on the website. Another teacher mentioned having one device for all labs because kids have a hard time going back and forth between computer and the GLX. One thing I see there is that the GLX is a small, portable, handheld device. And it's cheaper than a computer, so it's easier on some labs just to use the GLX. But if you want to do the data analysis, the very in-depth data analysis, using the graphical software, we have to use computers with those. Alright, and on further comments, one teacher said maybe already having Google Forms ready for students to use that they could share for labs. More student-made graphs using graphing software. And then here somebody just says that they think Science in Motion does a fantastic job providing support materials and they could not ask for more. So I'd like to thank that person for that compliment. Alright, so going back to the presentation, I want to look at research about technology in the science classroom. So I've looked at several research articles. This first one here is on teaching science with technology. It's case studies of science teachers' development of technology, pedagogy, and content knowledge. And they've actually abbreviated that TPAC. So I have something copied here from the abstract, and I just copied this straight from it, word for word. So the study examined the development of technology, pedagogy, and content knowledge, abbreviated TPAC, in 4 in-service secondary science teachers as they participated in a professional development program focusing on technology integration into K-12 classrooms to support science as inquiring teaching. In the program, ProWare, mind mapping tools, and internet applications, such as computer simulations, digital, that should be images, and movies were introduced to the science teachers. Teachers developed their own lessons and established learning communities with other science teachers. As a result of the study, here's the conclusions that they drew. They said well-developed programs that provide opportunities for participating teachers to build and sustain learning communities seems to have a positive impact on science teachers' technology integration. continuous support is necessary to help teachers overcome the constraints in incorporating technology. And so we see there that teachers can't do it in a bubble. They need help. They need training, practice, talking to other teachers, continuous support. The next research article is entitled Integrating Educational Technology into the Secondary Science Teaching. And so in the study, 3 beginning science teachers who successfully achieved technology integration were followed for 3 years to investigate how their beliefs, knowledge, and identity contributed to their use of technology in their classroom instruction. And so the results we see here, the findings demonstrate that the participating teachers were all intrinsically motivated to use technology in their teaching, and this motivation allowed them to enjoy using technology in their instruction, and it kept them engaged in technology use. The major findings of the study indicate that the internalization of the technology use comes from reflection, and that teachers' use of technology in classroom instruction is constructed jointly by their technology, pedagogy, and content knowledge. So again, we see that acronym TPAC being used. It also depends on their beliefs, their identity, and the resources that are available to them. Third journal article by Davies is Integrating Technology into a Science Classroom. It's an evaluation of inquiry-based technology integration. So in this research study, their findings and their observations was based on a 3-year evaluation in Indianapolis Public Schools. They looked at 6th grade science classrooms, and they used project integrated technology and a problem-based learning, or PBL, approach. Factors that were important to the process of integrating technology in an inquiry-based science classroom: 1, the concept of highly qualified and highly effective science teachers. They pointed out that just because a teacher is highly qualified does not mean that they are highly effective. 2 is the selection of inquiry questions and technology integration. 3, the need for technology training and technical support. 4, motivation to use technology versus using technology to learn. Because they noticed that students were motivated to use the technology, but most of them just wanted to play on the devices instead of using it to actually learn. And 5, the effective integration of technology to promote learning. Their comments were that technology can improve science instruction in a laboratory situation, but only when the learning activity is well structured and the equipment and materials to be used are well managed, allowing students to actually get to the intended learning task. They also commented that training and ongoing support are considered essential aspects of any successful technology integration endeavor. The last article that I want to look at reminded me a lot of our Science in Motion program here in Alabama. This article is entitled The Modern Science Lab, Integrating Technology into the Classroom is the Solution. And so from the abstract, they mentioned that they used a project called RAISE, which stands for Revitalizing Achievement by Using Instrumentation in Science Education. It was a partnership between Polytechnic University and 4 New York City high schools. Project RAISE seeks to enhance student academic achievement by using computerized data acquisition and sensory-based equipment in science labs. RAISE seeks to excite students about STEM and help them comprehend challenging scientific concepts. The grant used for Project RAISE provided plenty of money for stipends, but not for equipment. The schools were expected to provide their own computers, and many of the smaller schools had difficulty in doing that. The project only provided 4 sets of probeware, and oftentimes the schools had to share. Unlike our Science in Motion program, where the schools are sharing, but when we take out the computers or the small data acquisition devices, as well as anywhere from 8 to 12 sets of probeware. That way teachers can divide students into smaller groups. It helps to make classroom management easier. So, conclusion from this research article was that improved student attitude towards science, with some expressing interest in careers in science and in engineering, and that teachers improved their technical and pedagogical skills, as well as increased comprehension of scientific principles. So, looking at conclusions that I drew from all of this: 1, Alabama Science in Motion helps teachers implement the different standards, those IST standards, as well as the new Alabama Course of Study Science standards. 2, Alabama Science in Motion is aligned with current research by providing technology, equipment, training, and ongoing support to teachers, by establishing informal learning communities among teachers, and by increasing teacher technology, pedagogy, and content knowledge.